Capital shivers more than the mountains. Gurugram temperature dips to zero. IMD issues yellow alert. Why is Delhi colder than Shimla? The science behind Delhi's rare freeze.
Alright, this winter something unusual, almost unbelievable has been unfolding across North India. Cities known for choking heat waves and scorching summers are now recording temperatures colder than the mountains themselves. Delhi colder than Shimla, Gurugram touching almost zero, and suddenly the basic geography we all grew up believing seems to have flipped on its head. While for decades hill stations like Shimla and Mussoorie have been our escape from the plains, symbols of cold, comfort and crisp mountain air. So how is it that this January, the capital city of India is shivering harder than Himachal's hilltops? How are residents of Delhi NCR waking up to frozen winds, dense fog and bone-chilling mornings, while Shimla feels surprisingly less harsh? This is not a viral exaggeration, these are official weather readings backed by meteorological data. And they point to a phenomena that is far more complex than just its winter, because altitude alone does not decide how cold a place gets. Weather systems, air movement, pollution cloud cover, and even how our cities are built all play a crucial role. Why is this all happening now? Why is the national capital literally freezing as bad as hills? Let's dive into it. Hello and welcome to another episode of Xplained, brought to you by NewsX. My name is Vineet Malhotra and let's plunge into this terrible cold weather and the many possibilities. Let's look at the numbers, because this story isn't driven by perception, it's driven by hard data. On multiple winter mornings this January, Gurugram recorded temperatures close to 0 degrees Celsius. Delhi followed closely, dipping to 2 to 3 degrees in several parts of the city. At the same time, Shimla, sitting at over 2200 meters above sea level, remained warmer, recording minimum temperatures higher than Delhi NCR. Now pause and absorb that. A city in the plains barely a few hundred meters above sea level, colder than a Himalayan hill station, something that sounds geographically impossible yet meteorologically accurate. This is not a one-off reading or a faulty sensor. Weather stations across Delhi, Gurugram, Noida and parts of western Uttar Pradesh have consistently reported lower minimum temperatures than Shimla and even Mussoorie on certain days. And this is where the confusion sets in for most people, because we are taught one simple rule: higher altitude equals colder weather. But in reality, altitude is only one piece of this puzzle. Delhi temperatures depend on how much heat the ground absorbs during the day and how fast that heat escapes at night, whether clouds trap warmth or allow it to radiate away, and whether winds help circulate air or let cold settle and stagnate. In Delhi's case, almost everything lined up perfectly to make the plains freeze, while the hills stayed relatively insulated. To understand how this happened, we first need to clear a basic misconception: the difference between climate and daily weather. One of the biggest misconceptions about winter is the belief that hill stations are always colder than the plains. In reality, what we are experiencing right now is a clash between long-term climate patterns and short-term weather events. Climate tells us what a place is usually like over decades. Weather tells us what's happening today, this week or this winter morning. Shimla's climate is colder than Delhi's. That has not changed. But weather can temporarily flip expectations, especially during extreme events. Here's why: cold air is heavier than warm air. So when temperatures drop sharply at night, cold air flows downwards, settling in low-lying plains like Delhi NCR. Hill stations, on the other hand, often remain above this trapped layer of cold air. Add to this another critical factor: wind movement. Hilly regions tend to experience better air circulation. The plains, especially during calm winter nights, often see very little wind, allowing cold air to stagnate. Then there's cloud cover. Clouds act like a blanket, trapping heat close to the surface. This winter, the western disturbances brought cloud cover to the hills, keeping Shimla relatively warmer at night, while Delhi remained under clear skies, allowing heat to escape rapidly. So what we are seeing is not geography falling, it's meteorology taking over. And single most important phenomena behind this temperature flip is something called temperature inversion, a process that quietly turns cities like Delhi into cold traps. Under normal conditions, air temperatures decrease as we move higher above the ground. Warm air rises, cool air stays closer to the surface, and heat disperses naturally. But during extreme winter nights, this pattern reverses. This reversal is called temperature inversion. In simple terms, instead of warm air rising, a layer of warmer air sits on top of colder air, trapping it close to the ground. And once this happens, the cold has nowhere to go. Delhi's geography makes it especially vulnerable to this effect. The city lies in a flat, low-lying region surrounded by agricultural land and expanding urban sprawl. On clear winter nights, the ground loses heat rapidly through a process known as radiational cooling. With little wind to stir the air, the cold settles and pools near the surface, especially during the early morning hours. This is why temperatures drop sharply between midnight and dawn. Shimla, on the other hand, sits on elevated terrain. Cold air drains downhill from the slopes, preventing it from accumulating even when it's cold. The air does not stagnate the way it does in the plains. Another critical factor this winter has been the cloud cover. Western disturbances brought intermittent clouds over the hills, acting like a thermal blanket. Delhi often remained cloud-free, allowing heat to escape unimpeded. So while the mountains were insulated, the plains were exposed and frozen. This inversion does not just make nights colder, it also traps pollution, thick fog and moisture, turning Delhi's winter mornings into a dense, biting chill that feels far colder than the thermometer suggests. But temperature inversion alone isn't fully the entire story. There's another atmospheric player quietly shaping this winter. Western disturbances, the same systems that bring snow to the Himalayas. Another factor making Delhi colder than Shimla this winter is the presence of Western disturbances, low-pressure systems that travel from the Mediterranean into North India during winter. These systems bring clouds and precipitation to the hills, often resulting in snow in places like Shimla and Mussoorie. While the mountains get a fresh blanket of snow, the cloud cover actually traps some warmth, keeping minimum temperatures slightly higher at night. Meanwhile, the plains remain mostly under clear skies, allowing heat to escape quickly, which amplifies the cold. Essentially, while the hills experience snowfall and feel cozy under cloud cover, Delhi and nearby plains bear the full brunt of radiational cooling, making mornings sharper and colder than expected. Delhi's notorious air pollution and winter fog are making the cold feel even harsher. Smog traps moisture and reduces sunlight during the day, preventing the city from warming up quickly. Thick fog in the mornings also slows down heat absorption, so the streets and buildings stay icy longer. Unlike Delhi, hill stations like Shimla have cleaner air and less dense fog, allowing for better heat retention despite being at higher altitudes. Combined with temperature inversion, pollution acts like a thermal lid, keeping the cold close to the surface and making Delhi mornings feel much colder than the thermometer alone would suggest. Normally, cities like Delhi are warmer than surrounding rural areas because of the urban heat island effect. Concrete, asphalt, and human activity trap and radiate heat. But in extreme winters, this effect can collapse. When nights are long, skies are clear, and winds are calm, even concrete and buildings lose heat rapidly. Add moisture from fog and pollution, and Delhi's nights drop sharply in temperature. Essentially, the city's natural warmth is neutralized, leaving residents shivering while hill stations with cloud cover stay relatively cozy. This unusual cold spell is also a reminder of how climate change is affecting weather patterns. While overall global temperatures are rising, extremes, both heat waves and cold waves, are becoming more frequent and unpredictable. North India's plains are now more prone to sudden, severe cold snaps due to shifts in wind patterns, cloud cover, and snow in the Himalayas. What we are seeing, Delhi colder than Shimla, is a small but clear example of how weather extremes are breaking traditional norms and why residents need to be prepared for more unusual winters in the coming years. The unusual chill has left Delhi NCR residents scrambling to cope. Early morning commuters are braving dense fog, icy winds, and frost-covered roads, while school authorities have occasionally delayed start times to protect children. Hospitals report an uptick in respiratory issues, especially among the elderly and young children. Social media, as always, is full of memes and jokes about Delhi being colder than Shimla. But behind the humor is genuine frustration. People are layering up in extra clothes, lighting heaters and bonfires, and finding creative ways to stay warm indoors. For many, this winter feels stranger and harsher than ever, a sharp reminder that plains can be just as unforgiving as the mountains. So why is Delhi colder than Shimla this winter? It's a combination of temperature, inversion, cold air pooling, western disturbances, pollution, and a temporary collapse of the urban heat island effect. Add clear skies and calm winds, and the plains turn into a natural freezer, while hill stations stay relatively insulated under cloud cover. This phenomena isn't just a quirky weather fact, it's a reminder that our environment is complex and changing, and that extreme weather events can defy conventional wisdom. For residents of Delhi NCR, it's a call to stay prepared and adapt, while for the rest of us, it's a fascinating example of how science, geography, and human activity interact in surprising ways. Next winter, when the plains feel colder than the hills, remember it's not magic, it's meteorology, sending a clear signal that the rules we once took for granted are shifting in real time.
Capital shivers more than the mountains. Gurugram temperature dips to 0. IMD issues yellow alert. Why is Delhi colder than Shimla? The science behind Delhi's rare freeze.